Yesterday, I confessed that I do musical theater. But just because I do musical theater does not mean I'm bad at academics. And so to prove that, I will be applying the second easiest concept in calculus to explain happiness. Okay, so it's a little later in the day. I have more vitality and energy and life, which is a synonym for vitality. I was going back and editing the half-an-hour footage I recorded this morning, and I kind of wanted to die. So it was mid. It was really mid. So I'm gonna record something less mid right now. Let's talk about derivatives. Let's look at a graph of your progress as a function of time in months. So let's say this is maybe a year of time. What we see here is that, yes, you've made overall progress, but there's these little bumps within that, and that happens to everyone, where you start to regress a little bit, but then you rebound, okay? How do we determine if this person is happy or unhappy? Well, I would argue that happiness can be determined by progress per time. If progress per time is negative, then you are unhappy. If progress per time is positive, then you are happy. And if progress per time is 0, then you're just kind of like maybe living in some complacency from a recent success, or just kind of milling about, you know? Progress per time is basically the slope of any given point of this line. So at this point, the slope is positive, so we can say that this person is happy. And at this point, you can see it's kind of steeper than this point, which means that the slope here is greater than the slope here, which means the person is more fulfilled and more happy here, I would say. What about these points? What about this little month-long period right here? That is kind of a rut sort of deal. Now, there may be an easier way to be able to solve for happiness based on a progress graph for more complex equations that aren't just a series of linear segments here. And that is a derivative. We take the derivative. If I took the derivative of this, it would look something like, what I'm doing here with the derivative is just graphing the slope at each point. So this is still the time axis, but now this axis is progress per time. Slope of this, we can approximate that to look a little bit like 1. So it's 1 up until this point where it suddenly changes to -1, okay? Where up until this point where it suddenly changes back to 1. This can show us even easier the happiness of someone, and at any given point, we can plug in a time value and see if the derivative is above or less than 1. Then we can determine this person's happiness at any given point mathematically. So let's say the Calc BC exam tells you that Bob's progress graph is given by sine pi x plus 2. Find his happiness at x equals 2. How do we do that? Now, we do have this graph here that I drew as a visual aid, but pretend that the AP Calc BC exam did not give you that. I need an eraser. Did I forget the eraser? We can simply take the derivative. So, what is the derivative of sine pi x plus 2? That's a more complicated equation that requires actual derivative rules. I'm not going to tell you those because I don't want to. Just take my word for it. This is the derivative of that. So essentially this line will give us the slope at any given point here. So now I can solve for Bob's happiness. X equals 2, plug it in, cosine 2. Wait, no, I did my derivative wrong. This whole thing will equal pi plus 1, which is greater than 0. Therefore, Bob is happy. I don't know if you can tell, but I ran out of good ideas for videos, so. The whole point of this is to say, in a very, very overcomplicated way, bars, that rhymes. The whole point of this is to say something I've said before in a more complicated way. Now, your graph is a piecewise, and you can make that piecewise whatever you want. Oh, one more thing I forgot to mention. Let's say that you've done an intentional regression, because this whole idea, this whole stupid derivative thing was inspired by something I said in Intentional Regression is Intentional Progress, that video I posted like a few days ago, where I said, like, if you take the derivative of your progress graph, don't worry about it. In that video, I was talking about why it is a dignified, disciplined thing to be intentionally regressing if you think you might be pushing yourself too hard in a way that might harm you in the future. What does that look like? So you're making progress, and then you start to hit a tendon pain in your exercise or something, and you decide to intentionally regress. That's weird. Because this isn't a smooth curve, this is the whole thing. This is a discontinuity. How do you get a slope at that? Now, one of the rules of differentiation, you cannot differentiate at a point that is discontinuous. So we can do a continuity check, right? Step one, don't do the continuity check, just look at the graph, because continuity checks suck and they screwed me over in unit 2. It's okay though, I ended with an A. So let's take the derivative of this. What would that look like? So I'm just gonna keep going until I reach that point. What happens there? Well, it's indifferentiable there, so that's just gonna be a little hole. But that point where it's weird is infinitely small. So instantaneously after that, you'll be going right back to being above zero derivative, therefore happy. So, thank you for coming to my TED Talk. This is useless information. All right, well, goodbye.